So you have a 1980s General Motors car, Buick, Olds, Cadillac, Pontiac, Chevy, and the EGR isn't working right. Maybe you got spark knock, maybe you got a code 32, or maybe you've been doing the diagnostics and you're already down to the point where you understand that you've got a bad EGR solenoid, which is one of the causes of spark knock. And often you'll set a code 32 on the later cars where the diagnostic is in place. The replacement part, EGR Solenoid, for my TunePort 305 is out of production and no longer available. That set me off trying to understand what could be used as a potential replacement. My main topic is talking about TunePort injected Camaros and Firebirds and Corvettes, 350s and 305s. It looks like the carbureted cars use something very similar. I don't know that it's the identical solenoid, but its functionality is very similar. In the process of me digging into this, I learned from picking up from some third-party manuals that many cars back in the early 80s, many of the General Motors products, used the same type of solenoid that we use in the TunePort cars. I'm going to explain some of this in general principles that apply to those cars too. You know, the issue is that they use a normally open solenoid that the ECM closes when it wants to restrict EGR operation. And most of the newer cars have a normally closed solenoid the computer opens to allow EGR to operate. So as we go into this video, I'm going to show you that I found a solution. I found a new part. I'm going to test the part. I'm going to show you how it works. I'm going to go out and road test the car and see if this thing really works. But I've gone out and purchased a new part. This part will not apply to the 305 Camaros that have throttle body fuel injection. Those cars got switched over to a normally closed solenoid, and you can go buy that one, but it won't work on these. You know, I've spent a lot of time digging in and trying to understand what I could do, what would work, and how to make that go. So here goes. Just so we know what we're talking about, this is an EGR solenoid. This is the one. I removed it from my Camaro here. I guess let me give you a little backstory, a little background on what the issue is. Why is it discontinued? Why aren't there more around? This solenoid, port in and port out to the EGR valve, it is a normally open solenoid. That means when the power is off, it flows air through out to the EGR valve. Later cars, in the 90s, and even some later in the 80s, I think if you looked at Chevy trucks and so forth, they have a normally closed solenoid. So you put power on it and it'll open. And all the cars after that, cars and trucks, either have a normally closed solenoid or they went to what they call linear, electronically controlled EGR valves that don't even have vacuum on them anymore. So it appears to me that what's happened is all of the earlier applications that used normally open solenoid have been discontinued. And based on the other book here, you know, they're 3.8s, 3.8 V6s, 4.1 V6s, certain 5 liters. Not every engine, I got to be careful because not every engine needed one of these control solenoids. But those that did typically started out using normally opened ones. And let me explain why for a minute. All of our engines, starting with the carbureted ones, pre-fuel injection, there may be some that didn't have it, but almost all the carbureted engines had something called ported vacuum. What it would do is, you have a throttle plate in the carburetor, and there's manifold vacuum below the throttle plate, and there's air above the throttle plate. And if you have a port down below the plate, you get full manifold vacuum all the time. So then you have full vacuum when it's down below, nothing if it's up above, until you crack the throttle open and that port becomes uncovered and opened up. And then you'll get manifold vacuum up to that port. or near to manifold vacuum. And for many years, vacuum advance distributors worked that way. When the throttle was closed, you didn't have vacuum advance. When the throttle was open, if you used the ported vacuum, then your vacuum advance would come in. And it was a very common thing. When EGR started, you don't want the EGR valve opening when the engine's at idle or when the throttle's closed. So it was a very easy thing. From my cars in the 70s, you used ported vacuum to the EGR valve. And so the EGR valve was off until you cracked the throttle. And typically usually there was a temperature or a thermal vacuum switch or something in there that turned off the EGR until the engine warmed up. It was in that same hose. So bring in computers, right? Now you got a computer-controlled car. Instead of using all those thermal vacuum switches, the engine computer, the ECM, could easily control that vacuum if you put a solenoid in there. So you still had ported vacuum. You put one of these in so that if the computer wasn't controlling it, if it was off, the EGR valve just operated like the old ones did. It was just ported vacuum. And if you wanted to turn it off when the engine was cold or something, the ECM could power up the solenoid and make it close. But through most of its life, it was open and flowing vacuum, and the EGR valve worked, and it was all good. As we moved forward, later on, after, about 1990 or so on these tuned part cars, 92 I think they went to 92, when you get to the next generation engines, most of the throttle bodies on the fuel-injected cars got rid of the ported vacuum, and all you had was manifold vacuum. And so now, if you really want to control the EGR valve with vacuum, you wanted a normally closed one that the computer could open. And not only does it open it, it doesn't open it 0 to full. It uses something called pulse width modulation with a duty cycle, so that it's a variable solenoid. And this one out of this Camaro, it's a variable solenoid. The ECM actually will close the valve down and then let it open by taking power away from it until it opens up and flows and opens the EGR valve the way you want. I know that's a long story, but if you're working on your own car and you're trying to investigate and figure this out, you need to understand the basic principle of what's behind it, okay? When I found about this issue, I started out on a search, and I started by contacting the companies like Standard Motor Parts and emailed their tech departments. There are a couple of companies out there that sell these, and asked them I said, hey, you make a dozen of these for General Motors products. Are any of them normally open anymore? And I explained what I was trying to do, and they go, oh, we only make things for, that meet manufacturer specifications, and we can't tell you that. We don't know. And I understand. I'm just a YouTube guy, right? I'm just somebody I wished I could have got a spec sheet. Well, instead, I spent now about a month doing internet searches and doing service manual searches on the Chevys, on the Camaros, on mine. And then I looked for other models that had normally open solenoids that were still in production. Okay, I'm looking like at Standard Motor Parts list of EGR solenoids. I found one. And it's this one right here. It's a Standard Motor Parts VS25. And if you wanted to use it, the bracket won't match. It's got a stud in it, whereas my old one had a bolt going through instead of a stud. But you can either fabricate a bracket, you may be able to press that stud out of there, or it almost looks like it's threaded in. You may be able to remove that stud and find a way to bolt it to the same bracket. But for the sake of getting your engine to run, the bracket's not really a big deal. You fab something up. The main thing is you want something that works. And this solenoid is for a 4.5 liter Cadillac, like 88, 89, 90, and the 4.9 liter Cadillac. Those were both fuel injected engines, and they still ran a normally open solenoid, and you can still buy this one. This is the only one I can find. There might be more out there, but this is a variable solenoid, normally open. The coil resistances aren't identical. I don't know the flow curve on this new one, so I'm going to put it in the car and try it, but I'll show you in a minute a little more about that. The connectors are different, so you need different wires. The coil in this one is about 33 ohms. The coil in the old one, my current one, is about 25 ohms. GM service material normally says that the coils in these types of devices should be between 20 and 100. So 33, 34 is fine, no problem with that. Then to make this one work, it doesn't use a weather pack connector, it uses one of the, I think this is a Metropack series. And standard motor parts would call it an S575. It matches this one, and it'll snap in. Now, this one's got a plus terminal marked on the solenoid, so it's over to this side. So when I plug in this one, it matches up to the plus on the white wire. Looking at the Cadillac service information, the metal fitting goes to vacuum. This goes to your throttle body. And the plastic port goes to your EGR valve. Now, if you want to use one of these on one of your applications, you want to find the service manual for your engine and look for chart C7. It's a standard. All the EGR charts in GM's service manuals are, I haven't found one yet that's not under C7. And you'll see right here is the EGR solenoid, and it says NO, which means normally open. As I went through most of the other service information, I found that these just said normally closed. Now there is one caution. This is again for my fuel injected 305 tune port injected Chevy. I have a service manual from 1991 for this same car, and it says NC, and it's apparently a typo. It's not a normally closed solenoid, because it says NC up here, and then you read the description and it will tell you that it's a normally open solenoid. So just word to the wise, okay? First of all, I'm going to put a meter across and just show you I'm going to put a meter across and just measure the resistance of the solenoid. So we'll go across from, just hold them. Give it for a minute to come up. So see, I'm at 33.1 ohms. 33 is close enough. So that's good. And even though it has a plus terminal on it, if I turn these around and I go the other way, I still get 33 ohms. So the suppression device in here is probably just a resistor. But they intend for it to be polarity in a certain direction, so I would follow that. I've got a 9-volt battery here. I don't have a pulse width modulated power supply I can play with, so just so you can see that this works, you can hear it click when I put 9 volts on it, so I'm actuating that solenoid. I have a little vacuum pump here, and we'll hook the feed into the metal terminal, right like that. And I have a vacuum gauge attached to the outlet port. Let's see if we can get these so we can see them. But it's turned off, and I've got about 5 inches pumped in there, and I've got about 5 showing on my other gauge, and then it bleeds down. I don't know how long it's supposed to hold. My old solenoid, my current solenoid seems to hold a little better. This one bleeds off a little bit. I don't know what that rate might be, but I can pump it in here up to 5 and get 5. So it's open, normally open, no power on it. No power. Now if I go and put my 9 volt on there, positive to white and negative to black, and I'm just going to hold the terminals on the battery, and then we'll pump, and I've got 5, 10, or not, about 7 on the front end, nothing on the back end until I take the power off, and then it goes through again. And I've tinkered around with other batteries to see if I can get an intermediate state, and it does seem like it performs as a variable solenoid, which is what we want. My next challenge for hooking up for the test is, first of all, 2 things. And this one wasn't too bad, but this car has hard lines into this rubber adapter that goes with 2 ports that go to the solenoid. And I'm going to put a vacuum tee or jumper here and just use another length of this vacuum hose, because the new solenoid won't match. The ports are in a different position. But I can use some of these plastic tees. I'll pick the right ones, and I'll block off the tee so it's just a jumper from here to a vacuum hose, from here to a vacuum hose, and I'll go to the solenoid. Then my only real trouble is this is a weather pack connector that goes to the solenoid, and it is not a conventional standard. Normally these towers, see these towers have male pins in them, and normally I bought a pigtail that I thought would match up to that, but the male pins are in the shroud, and nobody makes a pigtail with female pins in the shroud that would match up to there. Let me be clear. I want to make a jumper so that I don't have to cut this wiring harness. I thought I could take and splice 2 pigtails together like that and connect this new solenoid into that connector. What I will have to do, well, for today, for my test, I have some jumpers that I've had around forever that have weather pack pins on them, and I will use a couple of these to jumper from this connector and dummy up a jumper that will go to this pigtail for purposes of testing. Here's my test setup. My new valve and the pigtail that I bought to go with it. And I've got some jumper hoses into the old molded rubber connector between vacuum and the EGR valve. And as I think I said before, this won't fit the new valve. So again, it takes some jumpers. I've got tees that I taped off. If I was going to do this permanently, I would just get some connectors to jumper to the hoses without having to do the tee. So I have individual jumper leads that are plugged in with weather pack pins that are plugged into the connector, and then I taped it to make it safe and electrically safe, and observed the polarity of the positive terminal, the positive terminal going in and the negative terminal going back. I taped off the hose here to the air conditioning for now. I'm just going to let that valve just ride on top of the fender. And I'll note that while my 85 car has a weather pack connector, if you're doing this, check your connector and understand what it needs to be able to make that connection there. Or you cut the connector off and connect directly into a new pigtail. In my case, I want to go back and put my old solenoid back in when I'm done. And if this works, I'm going to put this one on the shelf as a spare for the possible day when something fails. Now I know some of you are going to say, why should I fix this at all? It's just the EGR system. I can ignore the light. I can drive the car the way it is. And I've had a lot of reactions to that and talking to people, over the years with this. And I'll be straight up front. If you go back to the 1970s when they first introduced EGR, it was a very popular thing. A lot of people disconnected them because the cars performed better, because the systems were fairly early and, I'll say, primitive. The system worked, but they really didn't have it dialed in the early years, and so sometimes people would do that. Not supposed to, against law, but I can tell you I know it happened. But now, let's, I'm going to say fast forward to these computer-controlled engines. The systems have been refined. The EGR really isn't hurting you, and in most cases it's helping you. First of all, it's helping clean the air. And everybody wants cleaner air. You can kind of be a little cavalier about it, but your car contributes, and so help clean the air. Second thing is that from a performance standpoint, with these computerized engines like here, the spark advance curves are all adjusted based on the idea that EGR is present and working. And EGR lets you run more spark advance because it reduces peak combustion temperatures and takes spark knockdown. So EGR then actually increases your fuel economy because it cuts the pumping loss on the engine and it allows more spark advance. If it's done right, and these newer cars, they did it a lot better. And so I know today you can go on and you can find block-off plates and you can take out the EGR. If you do that, pollution increases. But if you don't go in and change all the calibration in the ECM, your engine will not run better. This Camaro, you'll never hear knock because it has a knock sensor and it'll pull back. And the algorithms for knock are when the knock sensor picks up knock, it cuts the timing back a long ways and then gradually tries to increase it again until it hits knock and then it pulls it back. And during that time when it's trying to bring things back up, your engine's not doing as well as it should. So best thing is to fix it and change the solenoid, change the sensor, whatever that you need to do. And it's better for your car, better for the air, better for you to have the system work rather than to just cut it off. Well, right now, I should have a functioning setup. And given that I have all the connections, I'm going to go take it out for a drive. And a fairly long drive, and make sure that it doesn't set any codes and that everything operates correctly. Alright, let's hammer it here on the merge and see how we do. I got some wind whistles up here. Every time I get a gust of wind, it kind of whines. Never got that before, but okay, so I'm 12 miles in at 75 miles an hour, give or take a little. Pushing into a heavy headwind, so there's good load on the engine. I've not backed off to idle, so there should have been plenty of time for a code 32 to set if one was going to. And so far so good. Driving great. I know I'm going to run about 4, 5, 6 miles here again, so run about 55 here on the old county road and see how things go. Well, I'm back in the garage with the Camaro after the test run. I wanted to make sure I got a very good drive, because if you go to the book, the diagnostics on a lot of these OBD1 cars, sometimes they were hard to trip even when you had something broken. The EGR diagnostic for this car says you need to have EGR percent above 27%, throttle not at idle, warmed up, and sustain that for at least 4 minutes. So if you're driving around in slow traffic, you'll never set it. So I wanted to make sure I got a good test, because I don't want to mislead anybody. So I made a loop, 49 miles from door to door, 3 stops, so that's 4 trips basically. Every time you stop you'll get another trip, so that if the diagnostic needs to see it more than once, it had that chance. It had 4 tries. Each one of those trips, while it had some low speed and stop and go, each of those trips also had a long duration, steady speed event. And I worked very hard not to take the throttle back to idle. I wanted to give it 4+ minutes on the throttle. So my first run out was like 55 miles an hour for about 8 or 9 miles, which is well over 4 minutes. After that first 10 minutes at 55 miles an hour, I made a stop and drove in town a little bit. And then I got back on the 4-lane and drove probably 4 or 5 minutes at 75. Made another, drove through town, made another stop. Then I spun around and went out the 4-lane for 14 miles at 75 miles an hour into a headwind. By golly, if you do, if I can't meet the conditions there, not trying hard enough. Then I made a gas stop. And then drove another, I don't know exactly, but another 10 miles and a 5 or 6 mile stretch of county road at 55 miles an hour again, without backing off. So, I should have been able to meet those several times. So anyway, I think it's good. The car runs just like normal. I can't tell the difference that I've changed this EGR solenoid. I'm going to put the original one back in, just because. And I'm going to go find a pigtail so that my jury-rigged pin-to-pin jumper wires, I'm not going to leave those in the car. But if you're having a problem with one of these, I'd suggest that you give it a try. I can't guarantee that it'll work for you, but it sure looks like it should. That's all for now.